In this problem, I'm given the quadratic equation 2x squared plus 3x is equal to 2, and I want to solve for x. One way that I could solve this task is to set my quadratic equation equal to 0 and try to factor it. To do this, I'm going to subtract 2 from both sides of my equation, giving me 2x squared plus 3x minus 2 is equal to 0. Now I need to try to factor 2x squared plus 3x minus 2 is equal to 0. I could do this by going back and using the factor by grouping method. In this method, I am looking for two numbers whose product is the same as 2 times a negative 2, which is a negative 4. These two numbers also add to my middle term, which is 3. I can see that two numbers that multiply to negative 4 and add to 3 would be a positive 4 and a negative 1. I can now rewrite my middle term 3x as 4x plus a negative x. This would mean that I would have 2x squared plus 4x plus a negative x minus 2, still equal to 0. Now in order to factor by grouping, I'm going to factor out the greatest common factor for my first two terms and my last two terms. If I look at 2x squared plus 4x, I can see that the greatest common factor is 2x. Factoring out a 2x out of my first term leaves me with x, and factoring out a 2x for my second term leaves me with 2. Likewise, if I look at my last two terms, a negative x minus 2, I can see that I can factor out a negative 1. If I do that, I am left with x plus 2. Now I can see that I have this x plus 2 in common in both terms. Factoring out x plus 2, I am left with 2x minus 1, and that is equal to 0. Now I can see that I have the product of two terms is equal to 0. My zero product principle says that either the first term, x plus 2 is equal to 0, or my second term, 2x minus 1, is equal to 0. Now I can solve each of these linear equations to determine my value of x. Subtracting 2 from both sides of my equation of x plus 2 is equal to 0 results in one solution of x is equal to negative 2. Solving my second equation of 2x minus 1 is equal to 0, I'm going to first add 1 to both sides, giving me 2x is equal to 1, and then dividing both sides by 2, giving me x is equal to 1/2. I can see now I have two solutions, x is equal to a negative 2 and x is equal to 1/2. I would like to verify that these are indeed the solutions to my quadratic equation. I will do this by substituting both negative 1/2 and 1/2, negative 2 and 1/2 into my equation. Substituting in negative 2, I would get 2 times a negative 2 squared plus 3 times a negative 2, and I want to check to see if that's indeed equal to 2. 2 times our negative 2 squared gives me a positive 4, and a positive 4 times 2 is 8. 3 times a negative 2 is a negative 6. So I can see that I have 8 plus a negative 6, which is indeed equal to 2. Now let's substitute 1/2 into my quadratic equation to verify that this is also a solution. I would have 2 times 1/2 squared plus 3 times 1/2, and I want to check to see if this is indeed equal to 2. Well, 1/2 squared is 1/4, so I have 2 times 1/4 plus 3 times 1/2, which is 3/2, and I want to see if this is again equal to 2. Well, 2 times 1/4 is the same as 1/2, and taking 1/2 plus 3/2 gives me 4/2, which, of course, is equal to 2. This tells me that x equal to -2 and x equal to 1/2 are the solutions to my quadratic equation.